Hi, my name is Karen and welcome to my project Enter the AI. The plan was to reuse some leftover LED diodes I had from my 3D Cube LED project and create two programmable rings with the brain being an Arduino Nano. Now, I was to utilize code from a prompt I gave to ChatGPT and see if it could be plug and play. Disclaimer, now I understand that AI is very frowned upon, but the basis of this project is to see how quickly project ideas can be formed from concept to creation. As far as the code, I will go ahead and upload it to GitHub, and I will also include the links to the 3D printable files and the wiring diagram for those of you who want to try something similar. Now, my stuff is not perfect, so feel free to remix it or fix it. And of course, I'm not going to take credit fully for like the code because it was done by ChatGPT, so essentially it's going to be on GitHub, and just like a disclaimer there. As always, projects are dangerous, especially these, because you will be using heat-inducing equipment and electronics, so try them at your own risk and ensure safe practices. And if you're young, have an adult with you to help you. So now, can AI be used to complete projects at a reduced cost of what normally would drive up the cost and time of prototyping? The short answer, yes. As you'll see, this video is going to go ahead and delve a little bit as to the process of what I did regarding the coding and the materials that I use. Of course, you need to solder stuff, so that's another thing. Let's begin. So the materials needed for this project, you're gonna need 5 220 ohm resistors, 1 per row, 10 3mm multicolor cathodes, although you can use any color, but if you want it to be a little bit more flashier, definitely go with multicolor. A breadboard, some breadboard wires, Arduino Nano. Mine is the USB-C one, but you can use an older one as well. Copper wire, a soldering iron. Now, I did list the soldering iron. Get the one that I linked so that you don't have to buy from Amazon, you can buy from anywhere else, but that one has most of the tools needed for even future projects as well. Now, optional items are a 3D printer. I use that because I'm still working on modeling, so I wanted to model a case for it, especially since I'm using a small display case, which is one of the other optional items to use for this project, because I wanted to see if I could fit everything in there. Spoiler alert, it does work. A button switch, which I had laying around with from mechanical switches, although you don't really need that one because you can trigger it from the computer, but I wanted to have it move from the computer to be on its own and displayed on like my bookcase. That's why I added a button switch for that, to switch through the different cycles of like flashing lights. And a pair of helping hands. Now, the helping hands do come in handy, and if you are planning on doing any future projects, you're gonna have to get these. So I did link the ones that I have on my link below as well, but like I said, you can get all these from like AliExpress or anywhere else. Now let's go ahead and get started with this project. I asked ChatGPT for a wiring layout, and from there I asked it to create a simple full modular sketch code that I could copy and paste into Arduino IDE. There are plenty of tutorials on YouTube that show how to set up Arduino IDE, so I definitely recommend you check those out, as I won't be showing you the full process here. I also asked to add specific effects like heartthrob effect and waterfall effect, and that a button was to be used to cycle through them, so that I could implement that into the coding. I then wired everything onto the breadboard for testing purposes and added 220 ohm resistor per row to help the longevity of the LED diodes and improve power management. And now that everything was tested, it was time to put it all together by soldering it. Now, there was a hiccup in the project, as one of the first mistakes I made was trying to solder the resistors directly onto the next row. That was a big mistake, and I definitely had to go back and fix it. Now the way I fixed this was I used the PCB board that I had, and I soldered the resistors onto it and then some wires to direct that current to the rings or the rows. I then soldered the brown wires to connect to the next row of the column, and that helped fix that issue with the resistors. Now in the process of fixing the new wires with the resistors, I also had to clean up some of the solder joints because they were shorting with each other. So yeah, that was definitely fun. Finally, I was able to test the connections and the soldering points again using the breadboard, and everything looked like it was working. So finally, I was able to test the connections and the soldering points again using the breadboard, and everything looked like it was working. So the final process was finishing the DuPont crimping. Now you don't need a DuPont crimper to do this, but I had one, so I used it. And of course, because I wanted to reuse my Arduino Nano C, I want to be able to just easily disconnect and reconnect. So that's the purpose for that. But if you want, you can solder directly. It's pretty much up to you. Now I did do one final test fitting for the project and everything worked. Final part of this project was ensuring that everything fits into a 3D modeled case. Now I'm not the best modeler, I'm still working on getting proper sizing done, and like I said, because everything revolved around fitting it inside the small little display case, it was essentially trial and error. So after the 4th time, technically the 6th time, the print was good with a little bit of filing, and of course it's not perfect, so I also forgot to include an opening for the USB-C. So of course we took matters into our own hands and we made an opening for it, but if I'm gonna go ahead and try to fix that in the final printed file on the printables as well. So just keep that in mind for the purpose of this video. If you see it looking a little off, it's because that was pretty much the penultimate prototype. I was happy with the way it turned out. It was pretty much easy from concept to creation. Easy in the sense of the coding. It was copy and paste, just how I wanted it, and it was easy to go in there and actually change like some of the speeds of some of the animations and whatnot, as it was all labeled. And as far as like the harder part of it was more of like the soldering and like the final 3D printing, all that, and part of that was because it wasn't just finalized. Like I think now if I were to do it again and I had it completely finalized, it would have been a little bit more easier. But because it was still prototyping, it was trial and error in some sections. And of course, I'm not a pro. I'm like a beginner to intermediate in electronics and dabbling in this. So yeah, I'm gonna give myself a little bit of break. And if you do decide to try this project, definitely tag me on the stuff that you build with it or using part of it, whichever. I love to see how people creatively create their own stuff. And I'm a big fan of like open source, and of course there's so many people in the makers community. Like, yeah, it's cool. Thank you, and please subscribe, share, follow, and comment below any other projects you want to see. Thank you. Bye.